Welcome to video 5 of tasks in Scala. In this video we're going to be talking about some very special functionality on lists, and the task you will be able to do after this video is to digitalize the menu of the Choco Café. That's a coffee shop here in Esteli, which I love to go to. I wrote down prices in dollars. I actually made this up because they pretty much have the same price for everything, but that will be a little bit boring. So for example, they have Frappuccino, they have coffee, latte, cappuccino. And then you can say, I want a regular one, or I want with a special syrup, with a special taste maker, chocolate, caramel, and creamy hazelnut. And later on, I will give you the final details of what to do in this task. Now, before we dive into the special functionality on the lists, we're going to talk a little bit about types. Until now, usually we've talked about, for example, integers. So I create a value int. I give it the value 5, and that's great. Now, a detail about this, I will copy paste this, is that actually your number has to lie within these ranges. And here I put the dots so I could try to pronounce it. I think this is 2 trillion. It's a very big number. So if you use an int, you have to make sure that it is between these bounds. There is actually another type you can use if you have a smaller or larger number, or if you're unsure, and that is called a long, and it's of the type long. If I write the type on this side and I assign 5, it immediately makes it into a long. If I would not tell the compiler the type and I would still want to make this a long, I just write a capital L, and the range for a long is this. So you can see that it's considerably larger. What is the difference? Well, a long takes up more space in memory. And that's also why it can be larger than an int. Now, in the tasks we've done so far, memory has not really been an issue, but this is just good to know. For example, in my own experience, I use a long whenever I use an ID, for example, for a person. It's always a good idea to use a long because you have no idea what's going to happen in the future, and you can think, well, I only have 1 million users, so this will be long enough, haha. But you don't know, and it's better to be safe than sorry in that sense. Not to use it for everything. If you know your number is going to be 5 or between 0 and 10, there is really no need for a long. So yeah, this is just good to know. And then we can talk about a different type, because we've only seen integer numbers, but what if you want a decimal number? In that case, there are 2 types you can use. A float with a T. For example, 3.14, my favorite decimal number because I love pies. And you would write a small f afterwards. And the other option is a double. 3.14. And you don't have to write anything afterwards. So if you don't have to write anything after, this is the standard that Scala will go for. And this is the standard that Scala will go for. Remember that, as I said before, if you write the type here, there's actually no need for the F. But if you don't write the type here and you still want to indicate that it's a float, then you should write a small f. Now, let's see, why is this lowercase f and this is a capital L? Well, let's just save and run. Okay, it does nothing because I'm not printing anything, but it did compile. Now, if I write a small l here, it actually gives me a warning. Lowercase l for long is not recommended because it is easy to confuse with numeral 1. Use uppercase L instead. So a very good reason. I think that makes it clear. So I change it back to a capital L. Let me just copy for you the details of a float and a double. Once again, this has to do with one taking up more space than the other and one having more precision. So for a float, you have a precision of 6 to 7 decimal digits, and for the double, it's 15 to 16. Now let's just print the float and the double so you can see what it looks like when we print it, since we haven't seen this before. And it both prints the same, right? but you have more space for decimals here. Great, now we're gonna go to mapping over lists, the fun functionality that I want to talk about today. Okay, we're gonna have a list with prices in euro. This is going to be a list of doubles. That's why I introduced the concept. Let's say we have 10.50, 11.25, 25, and 50. Note that I did not have to write a decimal everywhere. I didn't have to write this, but Scala will interpret it as such. But this makes my life a little bit easier. Let's just print it so you can see what I mean. Here it already put the .0. Okay, what if I want to know what are the prices in dollar? Now I know that today $1 is 1.22, €1 is $1.22. This can be different the day you're watching this, but let's just use this information. If I would transform the list of prices to the list of prices in dollar, then I would do 10.50 times 1.22. Then I would do it for each of the elements, correct? You just pass by all the elements and do exactly the same thing. So this is a little bit tedious because I'm repeating the same operation on each element. And we can summarize this as saying, well, on each element X, so this is an element from the list, we want to perform operation X times 1.22, right? This is what we've been doing. Now you could visualize it like this. You have this list initially, and you want to go to this list. You want to map this list to this one. And what happens at the place of the arrows is that you do times 1.22. So this is what you would call a mapping from one list to another. And that's exactly how it is called in Scala. Let's say we're going to create this new list of prices in dollar, which is also going to be a list of doubles. We take the original list of prices in euro, and then we map over this list. We say, well, each element X, it has to go to X times 1.22. Let's print this. Ta-da! And every position has been multiplied by 1.22. Okay, so this is how the mapping works. You determine what operation you want to perform on each of the elements, and then you use the map function on the list to create that. This little arrow, I don't know if you saw it, I made it by using the equals and then the larger than sign. And together it just combines to this cute arrow. Now let's try to do the same thing for Nicaragua and Cordoba. Today, €1 is 43.19 Cordoba. We can just do the same thing. So let's create a val of prices in Cordoba. It's going to be a list of doubles, and we're going to take as the base the prices in euro, and we will map over this list, and each element has to be multiplied by this factor. So we're going to say goes to X times 43.19. Let's print this as well. Fabulous. Now we have the prices in Cordoba. Let's try it with a different type of list. We're going to create a list of fruits. That's a list of strings. You can do this on all different types of lists. So we're going to have an apple, banana, pineapple, grapes, and mango. Let's see how I can get a list with the lengths of the words. So for every fruit in the list, I want to know what is the size of the word. What's the length of this word? Well, we can create a new list, length of fruits. This is going to be a list of ints, where before we would go from a list of doubles to another list of doubles. In this case, we're going to go from a list of strings to a list of ints. And we can simply use the map function again. And we say from every fruit, we take the size. Let's print this. Length of fruits. Oh, I made a mistake. Oh, I made a typo. Oh yeah, I see it. So as you can see, the error messages are really handy, and I make typos and then it already tells me. So here we get the result. Apple is 5 letters, banana 6 letters. Yeah, this seems pretty correct. So now you can see that you can also map a list of a certain type to a different type. Let's do something else fun. I want to create a list that says yummy apple, yummy banana, yummy everything. I want to create a yummy list. So we're going to take a fruit in the list and send it to a new string that's going to be yummy, and then append the fruit at the end. So glue the fruit at the end to the string. I didn't mention this before, but here I just used F because, well, it's a list of fruits, so I figured that F would be a logical choice, and here I use the X, but it really doesn't matter what letter or what word you use, because you could use a whole word. You could say fruit, and then here you have to say fruit. The only important thing is that what you put on this side is the same as on this side, because you're referencing to the elements. Okay, that was a little sidestep. Let's continue with my yummy fruits. This is going to be a list, not lost, a list of strings. We're going to map over the fruits, and we're going to take each fruit to a new string that is yummy plus the fruit itself. Let's print it. The yummy fruits. Yummy apple, yummy everything. Awesome. Let's look at an example that's a little bit more like the task that you're going to do. Let's say I have a bakery where I sell donuts, cupcakes, and a big cookie. I already want to eat it right now. And we're gonna create a list of the base products, and then afterwards someone can add a special flavor to it. So we have the base products, that is the list of strings, and we're just gonna list exactly what I said above, a cupcake or a big cookie. And then we're gonna have a list of flavors. This is also going to be a list of strings, and it's going to be chocolate. This is just going to be the list of chocolate and vanilla. Now, if I want to get the complete product list, that would be each base product combined with each flavor, I am going to map over 2 lists. Let's do it step by step. We take an element from the base product list, and what would we want to do with that? Well, we want to combine it with this element and with this element. And if there were more, we would want to combine it with those two. So you want to take the flavors map and map over this. Then for each flavor, you want to combine this with this. So you would say base product, a space, and then the flavor. So you would have a map within this map that we're already defining. Let's create a value of this. So we say all products. We're going to map over the base products. And for each base product, we're going to map over the flavors. And then for each flavor, we're going to first take the base product, then a space in between so it looks nice, and then the flavor. Let's print this. All products. And now you see we have a list, and within that list we have a list of the donut chocolate and the donut vanilla, a list of the cupcake chocolate and a cupcake vanilla, and the same for the big cookie. So we do have all the 6 different products, but we have lists within lists. That is not exactly what I wanted, but it is logical. For each base product, we map over the flavors list. And if we look at this part alone, let me just plug it out here. What will this give us? This is actually going from a list of strings, that is the flavors list, and this is just going to map to another list of strings, right? So for each of the base products, we get a list of strings. That is exactly what we saw here. So it is totally correct. It's only not exactly what we want. Now, there's a fun little thing we can do about it, and it's called flatten. It unpacks lists within lists. I would only have to add flatten here at the end, and it will unpack the elements. And now we have one list of all the products. And because this is a regular thing to do, they've actually decided that if you do a map and then you do a flatten, you can call this flat map. So here we see that we do a map and then we do a flatten. So we could make that into a flat map. Let's see how that works. We would say again, all products. Then we would take the base products, flat map over the base products, and for each base element we're going to do the same thing. We're going to map over the flavors, and for each flavor we create a nice new name, and then at the end we don't have to flatten because it's already in here. So it says for each base element we create a new list, but we take the elements out of the list, and then all of these elements together, they form the final result. So this will just show up as the same, a list with all the products. Okay, cool. So now we know how to iterate over 2 lists at once. There's actually a different way in which we can do this as well, and it's called for expression. Let me show you what I mean. We're going to create a new file, once again, all products, and we're going to create a for expression. And in the for expression, we say we take an element B from the base products, and then we iterate also over all the flavors, and then we yield, that means like produce, the base product plus the space and then the flavor. Let's print it so you can first see that this will actually give us the same thing. Oh, I made a typo. Print. Printlal. And this is the for expression result. So in a for expression, you can say, well, iterate over this list, and then for each of those, you're going to do the second step, which is iterate over this list. And then we yield some sort of outcome. So yield or produce or give, that's how you could interpret that. So you could actually do something really simple like the yummy base products, the yummy fruits that I did before. We can do it with the base products. And we could just say, well, for each base product, yield yummy plus the base product. Print this. And you see that it creates a list with the yummy donut, yummy cupcake, yummy baked cookie. Obviously, you don't have to do it like this because this is the same as the map that we did before. And this might look a little bit more difficult than a map. But in my opinion, if you map over 2 lists, then the for expression does look cleaner. And imagine mapping over 3 lists. If you would have to write that all down like this, you get lost. But then if you put it in a for expression, it looks much cleaner. The for expression has more functionalities. We will see that in a later video, but for now, this is all we're going to look at, just for you to get to know it. Okay, that was all. We're going back to the task for you that you can complete to digitalize the menu of the Choco Cafe. So we have the drinks, and then we have the options or flavors, or whatever you want to call it. And I wrote down the prices in dollar. The first thing that you should do for this task is to convert the drink prices into euro. So they are in dollars and we want to have them in euros, so we're only talking about the drinks. Then the second part is to generate the complete product list, so that would be to combine the drinks with the options. And finally, we're going to combine the stuff that we saw today a little bit with what we saw in the last video. So you will determine the cheapest and the most expensive drink based on the prices list. So you will have to determine what all the prices are and then decide which one is the lowest and which one is the highest. Just to say it one more time, you have to do this in code. Don't do it by hand. The idea is that you practice with all the concepts that we've seen until now. Okay, good luck, and I'll see you in the next video.